Here is a rundown of how timers work in Sysmac Studio. Because if you're like me and you're coming from like a script programming environment, timers on PLCs don't act the way you might think they should act. So this is the video I kind of wish I had when I started with this. And this is true to a lot of different PLCs. They generally have similar timers regardless of which PLC you're using. They might call them something different, but they tend to behave the same. Anyway, in Sysmac, you have a bunch of timers down here. Accumulation timer, off delay, on delay. And so we're going to go through some of these. So the first one, probably most common, is this on delay timer. So it takes an input, output when the time is met, your set point, and then how much time has elapsed. So if we turn this on, we have it set to 3 seconds. We can see it starts counting up when the 3 seconds is met. It turns on the output. When you turn it off, it kills the output and also it self-resets. So if we turn this on and we stop it before the set point is reached, it never turns on the output. So this is an on-delay timer. So this is common to use if you want to maybe start a fan or start a conveyor before you want other equipment to start. You can do it for like staggered starts if you got a lot of motors, a lot of fans, a lot of conveyors, something like that. And also safety, you can use it. I mean, you'd want to handle safety with the proper equipment. But if you wanted to like enable the buttons, like on an HMI, after the door closed and had settled for at least a second, so you're not getting some weird bouncing effect, that would be a good use of it. So the next timer is an off delay timer. So this one, when you enable it, you can see that we immediately get the output. We have our set point set at 3 seconds, and the elapsed time at the moment is 0. So when we turn off the input, de-energize, it counts to our set point, holding the output on until the time is met, and then it shuts it off. So again, it's as soon as the input is on, the output is energized, you turn it false, and it starts counting down. So you kind of use this maybe in opposite to an on delay. So you want staggered stops of equipment. You turn the system off, but you want like a cooling fan to run a little bit longer after the cycle stops. Same thing like a conveyor or something. You want it to run just for a few seconds, purge any material, whatever might be common uses of that. Again, the off delay timer is self-resetting. So if you turn it back on before it finishes, it will go back to your sustained on state. So it requires meeting your full set point before it'll actually turn off. Next timer is the pulse timer. So this one, as soon as you energize it, it only looks for a rising edge. So it only looks for a one scan cycle of input for it to start working. So as soon as you hit it true, you turn it false, it'll keep counting for, in this case, 3 seconds, which is our set point, in which case it'll reset after it's met. So it just requires one blip. Again, if you re-energize it, it does not reset. So you could do this as many times as you want, but once it's running, it's running. Hit it twice there. But it'll just run and it'll turn off when the time is met. So in this case, if you leave it on and it meets the set point, it'll still turn off. So it just looks for that one blip for it to do its thing. So common uses here are for if you want to, say, actuate an air cylinder for maybe 500 milliseconds in response to just like a sensor being triggered. And so you only want your input condition real briefly for an output condition to last a little bit longer. Also useful for maybe like a buzzer, like maybe some condition happens just briefly again, the sensor just picks something up and you want it to buzz for a second just to alert somebody. Common use of that. And lastly, our accumulation timer. This one is different than the rest in the sense that it requires a separate reset in order to go back to 0. So if we enable this timer and then we disable it, it holds the elapsed time. So our set point is set at 10 seconds, so it has not energized the output because the elapsed time has not reached our set point. But if we turn it back on, we can see it'll keep counting from where we left off. So we're getting close to our 10 seconds, turn it back on. And once the time is met, it will energize the output, and there we go. However, we set it false. It did not reset in case it actually holds its set point. So even though we keep setting this true, it'll never go above the set point, but it will remain on. So we have to reset it in order for this to go off. The lap time goes back to 0. Our value is true here. And then you would do true, even if it's not met, and we reset it. It still goes back to 0, even though the output never came on. So that's how you reset it. So this is commonly used for like a cycle timer. See how many parts you're running in so much amount of time, and because it's doesn't self-reset, it's helpful because it allows a user to pause the system in case they want to, open it, finagle with something, restart the system. Now you didn't lose your cycle time. It's good for like reporting total usage. Like runtime is not. It's pretty common to set this to just a really high value. Set it to 9,999 minutes, whatever it might be. And you don't really use the output. Instead, you just use your accumulated time, and then you can find out how much the system ran that day or something like that.